Hi, this is Kenneth Wong. I'm senior editor for DE 24/7. Welcome. And today we are speaking to Harshil Goel, CEO of Dyndrite. Harshil, aside from being a CEO of Dyndrite, how would you describe yourself? Do you have any other hobbies when you're not dealing with conferences and 3D printing?
Um, I would say I like to travel quite a bit. I'm a bit of a foodie. And ironically, I'm the kind of person who enjoys my work so much that I like reading technical papers in my free time. I think maybe that's maybe one of my personality defects. I'm difficult to turn off.
I wouldn't say it's a defect. It's a good thing in many ways. Let's go straight to something that I know you feel strongly about. Why do you feel like printing directly from CAD is the way to go and STL is not a good choice?
I mean, I think the answer is if you have the original CAD data, why use anything else? It's as simple as that. Right now, I do know that there are mesh-based formats and there are reasons to use them. Sometimes, for example, specifically in medical applications or reverse engineering applications. But truly, if you are printing something that was designed in a mechanical CAD system and you have the original CAD surface data, why would you not want to generate the toolpath data and the build from that original data and go through some middleman? The middleman only creates opportunities for pathological issues, delays, things of that nature. And so ultimately, simpler is better.
Why did using mesh format persisted for such a long time? Why did we even start using it as a mesh format printing process? And why didn't we from the beginning start using CAD? What was the problem?
I actually I provided Paul from 3D Printing Journal a long form answer to this, but I can give you the short form answer.
Okay.
In short, at the birth of what we would call 3D printing, um, you know, Chuck Hull and George Allen and a few other folks were talking. And in short, they wanted to come up with a simple way to send data to the machine to tell it what to do. Okay. And this is, I think, you know, 80s, 90s, give or take. And I mean, the idea of printing directly from the CAD data was always a thing. It was just more of, in my opinion, out of just sheer maybe laziness or computational practicality that people said, hey, let's take the original beautiful BREP CAD data, discretize it as a mesh, a linear approximation, and slice that so that we get a bunch of lines, right? So there's nothing that inherently prevented it, and there's nothing that inherently prevented it from evolving. I think it just was done once in the beginning, and people just said good enough, right? And I think that's kind of a view that good enough view, I think, pervades the additive manufacturing industry, which is why I also think that there are many problems in it.
Let's say that we all now agree that directly printing from CAD is the ideal method of doing this. Are there any technical issues or cultural issues that still stands in the way or prevent it from happening?
So I think the the main issues around printing from the native CAD data, right, are not necessarily technical in nature. They're mostly legal in nature because these are proprietary CAD formats, and in order to import them and manipulate them, you need to have special licensing. That said, those are all solved problems. There are folks like TechSoft 3D and DataKit and whatever who can help you with that. Once you get past that licensing hurdle, then the only other hurdle is, which is essentially the technical one, is when do CAD files fail, right? Right. Of course, CAD files can fail in the same way that STL files fail. They fail in, of course, different ways. Usually, the ways CAD files fail from experience are all the chamfers and fillets. And so, I'd say from a technical standpoint, most CAD data should be able to straight up be imported, sliced natively or discretized on a surface by surface basis and sent to the machine. The only real technical hurdle that could possibly remain is just CAD file fixing itself, because sometimes the loops on the surfaces don't come out right. But this is a much different and less, I think, pathological problem to solve that most of the CAD CAM companies have been solving for years in comparison to trying to fix these meshes.
Specifically from Dyndrite's perspective, what it is that you feel your company is able to do and is doing now to nudge the industry towards that direction?
So as I mentioned earlier, right, there was this sense of good enough. And so why switch if it's good enough? We are specifically developing functionality and features that relies on that CAD data, which comes with a much more robust metadata source to encourage people to go do things a different way, right? So it cannot be just a rip and replace. It has to replace and go further and provide value. And so we're doing a number of things in that vein. So, for example, one thing that we can do is most CAD data, you can put color on all the surfaces. Um, we can identify all of the colored surfaces and apply different operations to them. So, like, for example, I could identify all the green surfaces in the CAD data and put serial numbers on them. Or I could identify all the red surfaces and say, don't put supports here, right? There are these kinds of things that I think will help shift the mindset from good enough to actually this actually not just helps me get rid of this pathological issue, but actually helps me become more efficient and improves my workflow. And therefore, I have a much greater need to shift.
And recently, Dyndrite released a Laser Powder Bed Fusion Pro add-in. What can you tell us about that?
So it's I'll correct you there. It's not. It's less of an add-in. It's more of a desktop cam software. What does Laser Powder Bed Fusion Pro do? It allows you to do basically four key things. It allows you to do what I think people traditionally call build prep, which is import geometry, orient it, nest it, label it, support it, slice it, send it to the machine. I think there's nothing really fantastic about that beyond the fact that I think we're pretty performant and we have been native CAD from the very beginning in that regard. The second thing it lets you do is do something called materials and process development. So when you buy a machine, the first thing you want to do is make something specific on that machine in a specific material. And we provide you all the tools to iterate through the space to make sure that you can actually make that thing. The final thing here is on the qualification side. Um, you want to make sure you can make the same thing over and over again, of course, because otherwise it's not a production manufacturing process. And so Laser Powder Bed Fusion Pro, it's essentially just a CAM tool for additive, right? And we've specifically focused on the laser powder bed market because that seems to be the largest and the growing one. Though, of course, we can work with a bunch of the other methodologies as well.
I realize that you have lately been hopping different time zones, and it is because you're on a tour called You Control the Laser. What can you tell us about that tour and what's your goal with that?
So fundamentally, my goal is education, right? And I think I've been saying this almost for a decade now. We're at this unique point in time where the manufacturing hardware has surpassed the software. I constantly am surprised by meeting users of these kinds of technologies who are simply unaware of what their machine is capable of doing. And to be honest, I got a bit tired going to the usual trade shows. I also realized that the same people came to the trade show and some of the people who were actually doing the work didn't come. And so my thought was to bring that knowledge and education to them. And so we selected a number of cities with high concentrations of users. We throw this workshop for free. Um, Kind of the tagline for the workshop is anyone who comes to the workshop will know how to make arches and low angled builds, and they'll leave with that knowledge, right? So we're trying to demystify all of that. Everyone who comes to the workshop can bring their laptop and they can actually play with the software and learn it. They don't have to install anything. We just give them a cloud version so they can use that directly. And yeah, to circle back, it's just about education, right? The more educated our market is, the more sophisticated they'll be, the better constraints they'll put on the machine vendors, the material makers, and us. And ultimately, I think that's what it's going to take to grow this industry, right? If people keep making the same mistakes and wasting the same money due to those same mistakes, we're going to be continue to be stuck for the next decade.
All right, these are all the questions that I have, Herschel. Is there any last minute messages or last thoughts that you want to leave behind for the E24/7 audience?
I'd say if you haven't signed up for a workshop, I encourage you to do so. I think we do feedback at these workshops and they uniformly have glowing reviews. I think everyone leaves learning something and surprised by what they learn. So if you're unable to come to the next one, which is in Pflugerville, Texas, we'll be doing another one in Ohio around the America Makes MMX, and yet another one at ICAM. So I highly encourage you to come, learn, and share your experience. One thing though that is the same across everyone, everyone always wants the shirt with the logo on it and the posters. And so we've been bringing more and more of them to each of the road shows.
Very good. Herschel, thank you very much for spending time with us, especially on a Friday morning. I appreciate that.
Thank you so much, Kenneth.
All right, until next time, ladies and gentlemen, I'm Kenneth Wong, Senior Editor for DE 24/7, and we are out.